Hello guys, in the previous lesson we created the suspension car dynamics with the relation of the state space representation. Okay, and so in this lesson we need to create the Fyb force or produce this force in order to emulate our system with the proper conditions in the real life application. Okay, and so we need to add another Matlab function block in here. Okay, and so this should be linked to this one, and so we need to also add the clock value, which is the producing the simulation time, and so we can define this function block. And so the output of this thing is Ff the friction force or the moving force in our car dynamics. Okay, and so the input to t value is a simulation time. Okay, and should be added in here. And so in the first place we should create the dummy variable in here for the internal process of this code. And so another motion is that the t mode which is given by the t times 10 seconds. It's used to create a periodical force creation, because in every 10 seconds this code is repeated by using these modes. Okay, and so this is the range of this t mode in the seconds 0 to 10, and so we can condition this t mode in order to create a proper force dynamics or the force creation. Okay, and so if t mode smaller than 3 and then the ff int is assigned to 1000 Newton. Okay, and so in the first place up to the 3 seconds this code creates the 1000 forward force, and so the car is acceleration in this position. And then if t mode greater equal than 3 and t mode smaller than 7, this 4 seconds the ff should be selected as 0, and so acceleration is removed at this position. And so in the second place the t mode greater than equal 7 and t mode smaller than 10, and so ff int is equal to the 1000s but in the reverse direction. And so the car in the first place moving at the forward with the force of the 1000s, and so 3 and 7 these 4 seconds the car is not accelerated, or in the real life gas pedal does not pushed in this position. And so the ff int should be produced by 1000s up to the 7 to 10 seconds, and so which is the braking mechanism in our code. Okay, and so ff is equal to the ff int, and then our code is completed. Okay, and so how can we obtain the general notation of these things? We should add the dmax value in here, because the state variable is 2 times 1 vector at this time, and so we need to add the 2 scope variable in here, which is the theta, and theta dot car is the deflection ratio. And so if we run this program, and so we will obtain the true of this time. Okay, and so in the first place the theta car is deflected by the positive direction. Positive direction means that in this position, and so this turns up to this one. Okay, the up down theta is produced. And so in the second place we have the suspension effect in here. These oscillations comes from directly the suspension effect. Okay, and so in the second place ff should be equal to the 0. 3 to 7 seconds ff is not applied on this system, and so suspension can correct it at this position. Okay, and then the car is braking, and so the minus 1,000th force is applied on this car, and so the deflection is turned into the opposite direction, and so this theta is like this moving. Okay, and so how about our general forces? Because these terms whole is produced in the radian direction, but in our system we have the y position in here, y position in here. Okay, and so Kc produce or emulates the affected general forces in here, and so some forces consumed by the K or C, and so we need to obtain the full model. Okay, and then we need to define the general specific constants in here, like this one, y1, y2, and so f, b, f, y, f in here. Okay, because the back and front forces are important to design our car dynamics, because in the machine elements or the strength theory we need to create the 3D dimension model with the specific limitations, and so these limitations comes from these forces. And so in the real life, the Fyb or Fyf is the reaction force of the wheel dynamics, and so the rod or the any mechanism produced by the machine elements, and so they do not broken under these forces, and so we need to design these things by using the machine elements. The wheel can be loaded by using this force, and the wheel does not or cannot be broken under these forces. Okay, and so the Fyb, Fyf should be produced in here, and then what? The output section should be increased in here, and so in this first place, y1 is equal to what? Theta times Lf, because it's the front wheel dynamics, and y2 is equal to what? Minus theta times Lb, because the general direction is a reverse order, or direction of y is reverse, and so this is y1, this is y2, and direction is reversed, and so we need to add the minus term in here. Okay, and additionally we need to Fyf force in here. And what's Fyf force? It's the reaction force on this position, and it consists of the K and C value of our study. And so this comes from theta times Lf. This is the deflection of this definition, and so the Kyf plus theta dot times Lf times it is the y dot, and so Cyf should be added in here, and so Fyb is equal to what? Minus theta times Lb times chi Vb, and so theta dot times Lb times Cyb. Okay, these are general notation to producing the suspension systems, and so this suspension must remove this force in order to create a useful or balancing force in here. Okay, and so if you have a good performance on the car, and so these forces should be eliminated by the suspension system. Okay, and then what? We need to show these diagrams in here like this one, and so we need to add 1 scopes, 2 scopes, 3 scopes, and 4 scopes. Okay, this must be linked by using this scopes value, and so if we rerun this program, and then we obtain the total deflection in the front wheel. In the front wheel, 4 times 10 minus 3, or the 4 millimeter deflection on the front wheel dynamics, and so this value is our limits. And so if we run this car, and so if we accelerate this car with the 1000th force value, and so our car model up to 4 millimeter deflection rate on the front wheel. And what about the Y2? Y2 is the reverse of these things, and so we need to design the suspension system to remove 4 millimeter dynamics in here, okay? Because we don't want to use it in a normal position. Perfect car model or perfect suspension system design should give us this condition in the 3 to 700 position, okay? And so what about the Fyb forces in here? Fyb forces is the back front reaction force, and so this is up to the -400 Newton. And so it can be said that this suspension system should not be broken under the 400 forces in the running position, okay? And so you need to design this suspension system by using the K and C value, and so in the material science and machine elements you can learn it, okay? These are general conditions, and so you need to build a model in the real life application to carry these forces, the maximum forces in the real life application, okay? This is important to system dynamics, and so the importance point of these things is that in the time response characteristics we can deduce how can we design the suspension model or the car dynamics, okay? And so what about the second condition? The second condition is that LB is equal to the 1, LF is equal to the 1, okay? And so we can change it like this one, okay? And so this 1, but 1.7 and 3, okay? The LB and LF is different from each other, and so if we rerun this program and then we obtain the full time response characteristics in here like this one, this is changed or not? This is not changed because it's not affected by the LB and LF, because the reaction force removes to each other. But in the Y1 position, this value in the previous case is the 4, but it now is 1, okay? This is smaller than 2. But in Y2 direction, the total deflection rate is up to the 6 millimeter, and so this back deflection rate is increased by using this notation, and so as well as these things is increased, Fyb is increased, okay? Up to the what? Up to the 600 Newton. And so Fyf force is under to the 100 Newton. And then what about the result of these things? And so we need to design the greater design in the back front wheel for the suspension system, because the back front is take up to what? The 600 Newton in the maximum position, but in the front wheel the force is not override to what? The 100 is not access this 100 newtons, okay? And so you need to improve the design of the back wheel dynamics in here, but you can remove or you can decrease the performance of the front wheel dynamics in here, because the force is greater in the back, but the front is smaller than the back, and so we need to improve this design. And so if we can use or choose or change the value of the K by B in here like this one, -4 E6 E4. And so what about this? The YB and YB is increased with respect to the front wheel. And so what about the result of these things? And so we improved our design of car suspension system model, and so back dynamics is equal to the what? Up to 600, but in a smooth variable in here. Okay, and so YF is 10 Newton in this position. Okay, and so if we retrieve this car dynamics, and so we can use this notation because the LF 3.0, and so much of the force in here. Okay, and so these 3 and 4 and these 3 and these times. Okay, and so it's in this condition the front force is much more higher than back one. And so if you rerun this program, and then the front wheel is decreased up to what? Up to 200, and so front wheel is up to 300. Okay, it's much more useful to design of these things because the Y1 is equal to the up to 4 and Y2 is up to the 2. Okay, it's much similar than the previous condition. And so the front dynamics or front car suspension system is stronger than the back one with this condition. Okay, these are the specific advantage of the using the system dynamics model. And so we can observe the whole time response of these characteristics, and then we can design our models by using these techniques, because in the real life application you cannot easily change any material after the producing these materials. Okay, it's a cost, and so you need to design the system by using these techniques. And so you can observe that every generating value comes from this car dynamics balance. Okay, these are the study and the lesson of today. And so in the next lessons or subjects or contents, we will provide the control theory approach by using these techniques. Okay.